I'm going to work some examples for you from 11.2. Our essential question is, how do you simplify radical expressions? The first example I'll work is simplifying the square root of 32. Now if you look at that salmon-colored sheet that I had given you, the first step that you do when you're simplifying a square root is to convert it to a decimal so that at the end you can check your answer. So I'm going to write down what the square root of 32 is. So that gives me 5.6569. And I'm going to use that at the end to check my answer. The next thing you do is you write the radicand, which is that number under your square root, and you make a factor tree out of it. So I have to think, what prime number can I divide into 32? And the obvious one is 2. So I'm going to divide 32 by 2, and that leaves me with 16. And then I break down 16. I can also divide that by 2. It leaves me with 8. I'll divide that by 2, which leaves me with 4. Divide that by 2, which leaves me with 2, and then I'm left with all my prime numbers. I can check to make sure that I have correctly found my primes by multiplying all these numbers back into my calculator, and I should get 32. So if I do 2 times 2 times 2 times 2 times 2, as you can see, it gives me 32, which means I correctly found my prime numbers. The next step that you will see on that sheet is to circle pairs of identical numbers. So I have 2 pairs of 2's, and I'm left with a 2. So then you write those pairs under their own square root, and remember, everything here is being multiplied. And then I'm going to write this pair, and then that one that's all alone gets written at the end underneath the square root. Then you go through and you simplify each square root. 2 times 2 is 4, and that's underneath that square root. So I have the square root of 4, and as you know, the square root of 4 is 2. And then I'm going to simplify this one, which will simplify the same because 2 times 2 is 4, that's underneath the square root. And that comes out as a 2 because the square root of 4 is 2. But remember, everything here is being multiplied. The square root of 2 doesn't simplify, so I'm just going to carry it all the way down. These numbers are outside the square root, which means they should be combined. 2 times 2 is 4. And then my square root of 2 is left at the end being multiplied. So I think my final simplified answer is 4 square root of 2. And I can check that in my calculator, and this is how I'm going to do it. I'm going to take the square root of 2, and then I'm going to multiply it by 4. There's my square root of 2. If I multiply it by 4, notice how I have the same decimal here as I got at the beginning. That means that I correctly simplified it. So this is your simplified answer. Here's another example. This time working with variables. You use the same concept of circling pairs. Notice I don't have a number under here because I wanted us to just focus on the variables. I'm going to write this out in expanded form. Make a long square root. So x to the 9th means we have 9 x's being multiplied. And y to the 6th means we have 6 y's being multiplied. Then I can circle pairs. That x has to be left alone. And then just like with my numbers, just like over here where each circled pair got written by themselves, I'm going to do that with my x's. So this one becomes the square root of x times x. And as you know, the square root of x times x is actually the square root of x squared, because x times x means x squared. And from last chapter, remember that the square root undoes squaring. So the square root of x squared is actually just x. And then I'll do this pair also. Remember, everything's being multiplied. And of course I could write these steps down for these ones too, but they will come out exactly the same. So I'm just going to skip them all the way down, and they're going to come out as a single x. This one I'm going to leave till the end because he's all alone. So here's my y pair. It'll come down as the square root of y times y, which is the square root of y squared, and the square root of y squared is just y. Everything here is being multiplied. This pair would have the exact same thing happening. We'd write it down as the square root of y times y, which would be the square root of y squared, which would just give you y. So I'm just going to skip all the way down to here because it's going to look exactly the same as this line, and same with this one. So all of these things are now outside of the square root, but this guy got left behind. So I'm going to write him down right here. He's stuck under that square root. Everything outside of the square root can be combined. X times x times x times x can be written as x to the 4th power. Y times y times y can be written as y to the 3rd power. And then we have the square root of x left behind. Here's another example that contains a number and variables under the square root. The first thing I would do is see what the square root of 20 is, and I'm going to write that down as a decimal because it'll help me check my answer. Then I would start by simplifying that square root, which I would do by breaking it down into prime factors. So I need to think, what prime number goes into 20? I know that 5 does. You could pick 2 at this point, and you would get the same thing in the end as I would. So 20 divided by 5 is 4. 4 divides into 2 times 2. And again, you can check your string of numbers here to make sure they're right by multiplying them. 5 times 2 times 2 equals 20. Then you circle your pair, and the other one gets left by itself. Square root of 2 times 2 times the square root of 5. That gives you the square root of 4, which comes out as 2. The square root of 5 doesn't simplify, so it just remains behind. To check to make sure I do have the correct square root here, I'm going to make sure that it gives me the same decimal as the square root of 20. So I'm going to take the square root of 5 and times it by 2. And as you can see, that gives me the same decimal, which means I did correctly simplify this. So what's happened here is I've changed this 20 into 2 square root of 5. So I'm going to rewrite this problem as 2 times the square root, and 5 is underneath, and so is the x to the 10th and y to the 5th. And just like in my previous example, you can expand these out and circle your pairs. So I have 10 x's and 5 y's being multiplied. If I circle my pairs, this one gets left behind. Each one of these underneath the square root can be written together. There we go. And then at the end, notice this 5 is stuck underneath the square root, and so is this y. So they get written at the end together. And out front is my 2. If you remember from the previous example, when I had a pair under the square root of x times x, that became the square root of x squared, which just came out as a single x. So using that same idea, I know that this is going to become the square root of x squared, which just comes out as a single x. So I'm going to do that with all of these pairs. This is going to come out as an x, this is going to come out as an x, and this square root is stuck. And don't forget we have a 2 in the front, and everything here is being multiplied. So I have 2 out front, 1, 2, 3, 4, 5 x's being multiplied, so that can be shortened to x to the 5th. 2 y's being multiplied, y squared, and the square root of 5y at the end. That is the simplified form of this problem. I'll do an example with fractions. From your notes, remember that we don't like square roots in the denominator, and to get rid of them, you can multiply by that square root. But what I'm actually going to do first is I'm going to do the decimal form of this so that we can check our final answer. So I'm going to take the square root of 7, and I'm going to do 5 divided by that square root of 7. So 5 divided by this number. So this whole thing has a value of 1.890. That'll help me check my final answer. Alright, to get rid of the square root in the bottom, I make sure that it's simplified, which it is. If I tried to break down that 7 with a prime factor tree, I would get 7 and 1, which as you can see wouldn't break down because there's no pairs there. So I'm going to multiply by the square root of 7, top and bottom. On the top, that gives me 5 square root of 7. On the bottom, I can multiply these square roots. 7 times 7 is 49, and that's underneath the square root. So on the top, I have 5 square root of 7, and on the bottom, the square root of 49 is just 7. The square root of 7, remember, can't be simplified, so I'm done at this point. But I can check my answer by taking the square root of 7, multiplying it by 5, and then dividing it by 7. Notice how I got the same decimal as I had gotten previously. That means that these two answers are identical. This is just the simplified form. And that concludes my examples.